Hi everybody, welcome back to Science. I'm sorry it took me so long to get this video up. I originally recorded it and then I realized it had no sound and then I tried to re-put it up here and then it wouldn't go. So this is like take 6. So let's see how it goes. Hi, welcome to Science everybody. We are going to be beginning our unit about matter and its interactions. And you have these slides that we are going to be looking at. And your job today is to follow along with the video so that you can fill in the boxes and the area and just follow along with the notes, and then afterwards you'll turn those in. So we are in matter and interaction. This is instructions for use, but it's exactly what I just said. So I'm going to move myself over. The question is, what is matter? And we kind of talked about this a tiny bit, but here we are actually going into it. So what is matter? Matter is everything or anything that can be seen, touched, smelt, or felt. So that's what these lines are going to be. You're going to have seen, touch, felt, or smelled. So you can pause the video here if you'd like so that you can put those in. And I'm going to keep going now. So if you need to pause, make sure you hit pause. In other words, matter is anything that has mass and can take up space. So next, I have this little video that we're going to watch.
Hey, what's matter? No, not what's the matter. Obviously, since you're here with me, you're pretty awesome at the moment. You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space. You already know about weight, right? That's just how heavy something is. Like if you've ever been to a doctor's office, the first thing they do is have you stand on the scale so they can measure how much you weigh. As for taking up space, another way of thinking about it is that all matter has volume. It simply fills the area it's in. When you pour water into a glass, for example, the water's volume is the amount of space that it takes up in the glass. So all matter has volume and weight. But it sure doesn't all look the same. Well, that's because matter comes in different forms, or states. Liquids are a state of matter that I'm sure you're familiar with. If you've ever poured yourself a drink while trying to watch TV, you might have noticed that liquids take up space, because once the space inside your glass is full, right on the carpet. Sorry, Mom. You also know that water has weight if you carry a water bottle. As you drink from it, it gets lighter because you're removing water from it. Solids are matter too, of course, probably the most obvious kind. Rocks are solid, and so is ice, which is just solid water. Soccer balls are solid, iPads, your pet Fluffy, and every single guy in One Direction. And just like rocks, all those things have weight and take up space. Now, you know what's weird? Sometimes matter can't be seen or felt, but it's there. Like the air we breathe. Air is an example of gas, the third main state of matter. And I probably know what you're thinking. How do we know air, or any gas really, is there if we can't see it? Well, we can prove it by doing an experiment. Science. Let's start by asking the question, is air matter? Because if it is, it should take up space and have weight, right? To see if air takes up space, look it, I can easily drop an empty balloon into this little box, but a full one won't fit. That's because the air that fills the space inside the balloon is bigger than the space inside the box. Now, does air have weight? Let's try something else. Take 2 empty balloons and tape them to the ends of a meter stick. Then we'll hang the meter stick on a string so that it's perfectly balanced. Now let's see what happens if we blow up just one of the balloons and put it back on our meter stick. Check it out. The end with the full balloon sinks. It weighs more than the empty balloon because the air gives it extra weight. The balloon full of air will always weigh more than the empty one, because air is matter and matter has weight and takes up space, whether it's a liquid, a solid, or a gas. So listen, the next time someone tells you that something doesn't matter, you can tell them to their face that technically everything is matter. And tell them Sabrina said so.
Awesome. So, yeah, that's basically kind of just like a little introduction to matter and what matter actually is. But if matter is anything that can be seen, touched, felt, or smelt, then what is matter even made of? So, the smallest unit of matter, meaning if you were to chop up a piece of metal into a million bajillion pieces, the smallest bit you would be left over, or the smallest bit that would be left that had some properties of the metal is called an atom. ATOM. So if you want to, you can go ahead and hit pause right here. And here is where you can change it to say atom. ATOM. So go ahead and hit pause. And then I am going to continue now. So the smallest form of matter is an atom. So let's take a look at what an atom looks like. This is called an atomic model. So here we can see electrons, these little green guys on the outside, protons, the blue guys on the inside, neutrons, which are the pink guys on the inside. Then here it says that the combination of protons and neutrons is a nucleus. And something I want you to remember, that a model, so this is called an atomic model, this drawing, is a way to represent something that we can't easily see. So let's look at the different parts of this. So protons are, if you look at this picture, protons here in the middle, look at them, they have a plus sign. In science, a plus sign is a good way to show that something has a positive charge. So if you want to go here and type in the word positive, you can go ahead and hit pause here so that you can go ahead and do that. And then I'm going to continue on. So even though an atom is the smallest bit of matter, there still are these smaller sections still. So here we have the protons, positively charged particles. Next, we have electrons, and here we have little minus signs on them. So if a proton is positively charged, then an electron is going to be negatively charged. Electrons are negatively charged particles. So if you want to hit pause right here, you can go ahead and fill that in. And then I'm going to continue. The thing about atoms is that they like to be balanced. So typically, the number of protons are going to be similar to the number of electrons, but we'll get more into that later. So electrons are negative, protons are positive. You can kind of remember that because P for proton is positive. Electrons are negative. Moving on, we have neutrons. So the word neutron kind of sounds like the word neutral. If you are neutral, that means you don't really have a side. Let's say two of your best friends are arguing and you don't want to pick a side. You don't want to be with, let's pretend it's colors, you don't want to be with the blue side or the green side. That would make you neutral. And so neutrons are neutrally charged particles. Neutral means you don't pick a side. It means they're not positive and they are not negative. So they have no charge. So you can go ahead and hit pause here so you can put that answer in. And I'm going to continue. So an atomic model. Protons and neutrons stick together to form the center of an atom, and we call this the nucleus. Because of the protons, the nucleus has a positive charge. So here, because these neutrons, they're neutral, because the protons are sticking to them, that makes them positive. But if you were to take the protons off, they would be neutral. But since the protons are stuck to them, it's going to be positive. And it's hard to see in the picture, but electrons are always circling around or orbiting the nucleus. But truthfully, scientists can't even tell you exactly where because they're going so fast. So atoms, literally everything is made of atoms. Everything is made of matter. So it goes, atoms create matter. A bunch of atoms together make matter. But how? So there are lots of different types of atoms in the universe, and we can tell the difference based on the number of protons. Remember, protons are those positively charged particles inside. So we have protons. And as far as scientists know, there's about 100 different combinations of atoms, 100 different versions of an atom with a number of protons. One of the most popular kinds of atoms that we have on Earth is called hydrogen. If it has one proton, so right here, this one in the middle, one proton is going to give you a hydrogen atom. Another very popular element we have here on Earth is called oxygen, and it has 8 protons in here. And it's kind of hard to see, but it has a 8 on it. And if you kind of look, if it has one proton for hydrogen, it also has one electron. This has 8 protons, and we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. They're usually in balance. I say usually, but we'll talk about what happens when they're not. So we have these 8 protons. And when you have 8 protons, it makes oxygen, just to reiterate. So you might have recognized hydrogen and oxygen as being the names of 2 of our elements. Atoms are the things that make up elements, and you may have seen this before. I'm going to go to a bigger version. So this is the periodic table of elements. The way you can tell which element it is by the number of protons. So right here is hydrogen. That means I have 1 proton in there. And they go in order. It goes 1, 2, 3, and then counts up just like that. So this is our periodic table of elements. And we'll look at this a little bit more later too. So, okay, great. We have atoms, but they're so small. How do they actually make anything? Well, when 2 or more atoms combine, that's when they create something called a molecule. A molecule is literally 2 or more atoms combined together. So you can go ahead and hit pause right here so that you can record your answer in. And then when you're all set, we're going to go on to the next slide. So a molecule. A molecule is a neutral group of 2 or more atoms being held by chemical bonds. That's really complicated, so don't worry about it. You don't need to worry about the polar covalent bonds or the ionic bonds. I literally didn't even learn that until high school, so don't worry about that. I just like the illustration. So there are 2 different ways we see molecules. We have molecules of elements, which means you have 2 atoms that are exactly the same. 2 or more atoms that are the same, I should say. So here we have 2 hydrogen atoms, and since they're together, it becomes a molecule of hydrogen. Here I have 2 oxygen atoms together, and since they're together, they make a molecule of oxygen. And then here I have 2 chlorine atoms put together, and since they're together, they make a molecule of chlorine. So a molecule is 2 or more atoms put together. Now it gets a tiny bit tricky when you start getting a different combination of atoms. So here I have 2 hydrogen atoms and 1 oxygen atom. When that happens, I get what's called a compound. It's a compound because I'm combining different types of atoms together and creating a molecule. So molecules are basically just when you have more than 1 atom, but if it's different kinds of atoms, you get compounds. So 2 hydrogens and an oxygen, when these atoms get together, that's what creates water. And here I have 1 hydrogen atom, and I'm combining it with 1 chlorine atom, and together they make a molecule. But since they're different, I also get a molecule of hydrogen chloride, and it makes it a compound. So for our last slide for today, we have blank makes up blank, which makes up blank. So the smallest thing we have is an atom. Atoms make up elements, and elements make up molecules. And if you look in this illustration here, we have these atoms. Since I have an oxygen atom with 2 hydrogen atoms, that is a compound. So you can go ahead and hit pause here so you can finish that up. But truthfully, that's all I really have for you today. You all did a great job. This is a lot of information in one go. If you have any questions, of course, let me know and I'll be right there to help you. But that's all I got for you today. So thank you so much, everybody. Bye.